In this video, we're going to look at finding the square root of a complex number. Now, because we know the square root itself is going to be a complex number, we can say that the square root z is written in the form x plus iy. We call x the real part and I the imaginary part because it's the coefficient of I. In that case, we can say that, because if that's the square root of the answer, we can say that when you square it, you actually get the function that you're trying to find the square root of, if that makes sense. We now apply the square root to both sides. When you do, you can say that z is equal to the square root of 21 minus 20i. Now that you've done that, you can express z in the form of x plus iy. So you can say x plus iy is equal to the square root of what we just introduced, 21 minus 20i, and you can square both sides. And that will get rid of the square root on the right hand side and give you a function that you can deal with. When you square the left hand side, well, squaring a bracket just means multiplying it by itself. So this becomes x plus iy multiplied by x plus iy. I'm sure you guys may have seen this earlier on in A-level maths or even GCSE maths. X times x is x squared. X times iy is ixy. Iy times x is again ixy, which is why I've written out here. So let's write that out as 2ixy. And then plus iy times iy is I squared y squared. That's positive I squared y squared. And because I squared is equal to minus 1, using what we know about imaginary numbers, we can write this out as minus y squared. So we can attach that to the end of this function here. You can make that now equal to 21 minus 20i. Once you've done that, you can equate the real parts and the imaginary parts to each other. The real parts are x squared and minus y squared. So you can say x squared take away y squared is equal to the real part on the right hand side, which is 21. Now the imaginary part on the left hand side is 2xy because that's the coefficient of I. And you can make that equal to the imaginary part on the right hand side, which is minus 20. Now with the imaginary part of the question, you can divide both sides by 2 and you get xy is equal to minus 10. We now have to somehow combine these equations together to get the values of x and y. Once you've got x and y, you can just input into this expression and say that's the square root of this function here. So how do you do that? Well, you can make x the subject of this equation, so x becomes minus 10 over y. And now you can replace x squared in this expression with what you just introduced. So it becomes minus 10 over y all squared minus y squared is equal to 21. When you square this, let's write this out separately because it might help squaring. So minus 10 times minus 10 is positive 100. So I just realized my pen is very thin. Let me make it even thicker. Divided by y times y is y squared, and you take away y squared is equal to 21. In order to solve this, I'd recommend multiplying each individual term by y squared. When you've done that, the first term becomes 100, the second term becomes y to the power of 4, and the last term becomes 21y squared. If you now take everything to the right hand side to make this a positive y to the power of 4, we get y to the power of 4 plus 21y squared, take away 100 is all equal to 0. I'm sure this looks familiar to you because it's actually a hidden quadratic, or you may have heard it as a stealth quadratic. In this case, if it helps, you can introduce x as the middle term, y squared, and that will make it so that this expression now becomes x squared for y to the power of 4, because when you square y squared, that's y squared times y squared, which becomes y to the power of 4. And then this becomes plus 21x minus 100 is equal to 0. And then in the bracket, it might help you deal with it, but it'll be a positive 25 and a negative 4. And that gives solutions of x equaling minus 25 and x equaling 4. Now, although we're dealing with complex numbers, real and imaginary parts, x itself, if we go back to the beginning of the question, is a real part. Oh, sorry, I just realized I introduced x as y squared. We need to reverse it back into y squared. So now that we've got values of x, we now say, okay, if that's what x is equal to, y squared is equal to either minus 25 or 4. Like I mentioned before, y, again, it's a real number. It's a real part of this coefficient of I. So that means you can't have a negative root. Instead, we only focus on this root, and well, when you square root it, there'll be two answers, either y equals negative 2 or y equals positive 2. Now that we've got these two roots, y equals minus 2 and y equals positive 2, we need to think about how to find the value of x. Well, the easiest way is to look at the equations that we formed, these two equations which we know to be true, and you can substitute y equals, let's use the second one, xy equals minus 10. You can replace y with minus 2 in each of these and find the value of x. So when you replace y with minus 2, it becomes minus 2x equals minus 5, minus 2x equals minus 10, and x is equal to 5. when you put y equals minus 2 into this expression, you get 2x equals minus 10 and x equals positive 5. Negative 5. Sorry, even I'm getting confused. Be careful with them pluses and minuses. And so the square roots of the complex number is where z is equal to x, which is, well, either 5 minus 2i, or z is equal to minus 5 plus 2i, because y would be positive 2 for that value of negative 5x. And again, the reason why this works is because we introduced z as the square root of this whole complex number. And we also said that z is equal to this or this. Hopefully that all makes sense. Quite a long process, but hopefully after you've done it a few times, it's nothing too difficult, I don't think. It's just, yeah, pretty long process. Yeah, be sure to like the video if it helped and subscribe. I'd appreciate a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.